go ahead and introduce some fundamental topics, right? Some key vocab for our class. Of course, right, we're learning a new programming language, so let's go ahead and define that term. So, programming language is a formal set of instructions used to communicate with a computer. So, it allows humans to write software for computers. Software is essentially instructions. So, we can tell the computer what to do, right? And it has them perform tasks or control specific hardware. Maybe you have a control the camera, right? Maybe you have control the screen. Maybe you have a control the actual hardware resources, right? Like CPU and memory. So these languages usually consist of two main aspects. That's going to be syntax, so the rules about how the code should be written. So if you're writing in Python, it's going to have its own rules. If you're writing in JavaScript, it's going to have its own rules. And in this class, right, we're learning Java, so we're going to learn those set of rules. And then there's semantics, so what the actual code means, right? So syntax and semantics. So programming languages, they come in three main levels. Sometimes people just really group them in two levels. But depends on how you ask. You can definitely go with three levels. The two most important levels are the high and the low. And then again, some people consider there is a mid level of languages as well. So high level languages, those are the easiest for humans to read, write, and understand. Easy, right, in quotes. Of course, it's not easy to pick up a programming language, but it's definitely easier than a low level language. And we'll explain why in a sec. So high level languages, some examples include Java, C++, Python, Ruby, JavaScript. Mid-level languages, so they're going to be a balance between the high-level abstraction. So abstraction means it's making it easier for you to use, right? When you're abstracting what a machine does into human language, you're essentially translating some really difficult instructions, right, into actual human words, such as print or input, right? Those are actual keywords we're going to use throughout the class. Um, and actual commands, right? We're going to use a print command when we actually get to coding. So yeah, mid-level languages are kind of in between. That would be C. That's a programming language that a lot of the high-level languages are actually based on. And C++, notice it is on both. Some people consider it a high-level language. Others consider it a mid-level language. One of the characteristics as you go lower, so now we're entering mid, right, and then low, is that they give you more hardware control. So they're going to give you a lot more fine-tuned control over the hardware resources. So a lot of these lower languages, when we get to mid-level and low-level, they're really useful for computers that have limited resources, right? Where you really, really have to think about how efficient the code is, right? Controlling the actual hardware. When that stuff matters, you got to go to the mid-level, low-level languages. When you're just creating software, right? Just trying to get things to work, and you're not really worried about the actual hardware itself. You're just creating general purpose software. Then of course, high level languages is for you. And then at the very bottom, we have here. Sorry, got a little bit of a lag here, so I'm gonna reset that. There we go. So low level languages. So these are languages closer to machine code and provide little or no abstraction from the computer's hardware. So if it's no abstraction, that would be machine code itself. That's how actual computers read data. There is one just right above machine code. That's assembly language. As a computer scientist, earned my master's degree. I actually took a class where I had to write programs in assembly language. So things that would typically take one line of code in Java or Python, in assembly language, it could potentially take an entire page, right? So that's definitely, as you move lower into the levels, it becomes more difficult, but it also becomes closer to what actual computers read. So why Java? Why should we learn Java? What's the utility of it, right? Of course, you're taking a class. You're going to want to know, is what I'm learning actually useful? Is it used in the real world? Well, let's first define what Java is. It's a high level, as we discussed, object oriented programming language that was designed to be platform independent, meaning you can write code once and run it anywhere. So, back when Java was first being developed, you actually had to write code specifically, right, for the system that it was running on. Java kind of revolutionized that in a sense that it used something called the JVM so that you could write your code and you wouldn't have to worry about the system it was running on. That JVM would be a layer in between the actual machine that you're running on and the code itself, and kind of handle the translation, right? Making sure that those things integrate well and are compatible. We'll discuss that more though in some of the later slides. I know that can sound kind of like rocket science, right? I promise you, once we get through some of these slides, it'll make a little bit more sense. So Java is built around the concept of objects and classes, which means everything in Java is treated as an object, which makes it easier to model real world systems. Say you're coding for a car sales company, right? Some of the objects that you're gonna write in Java would be the car itself. Maybe another object would be the customers, right? For your car dealership. Everything in Java, you treat it as an object. So we're going to be using that word object, especially when we get later on into the end of the class. So it follows the principle of write once, run anywhere. Again, is all about, hey, I can write this code, it's general purpose, and I don't have to worry about where it's running. Java will always run no matter, right, the platform. So that was kind of one of the leading principles behind creating Java. So code written in Java can be executed on any platform that has a JVM. So we're going to actually download a JVM onto your computer. And that's going to be the part that translates the Java code into machine code. So please go ahead and watch this video on Java from one of my favorite YouTube creators, Fireship. I've learned so much from Fireship in my own computer science journey, my own programming and developer journey. So when I thought, hey, what could be a good place to start for this class, of course, I went with one of his videos. So go ahead and watch that on your own, and when you're ready to continue with ours, you can just hit next on our playlist. All right. I'll see you on the next video.